Okay, today's learning goal you can see is we're going to fit a line to data. So all we're going to give you is a bunch of data points in particular, and you're going to have to come up with an equation that is the best fitting equation for that series of data. All right, to start that, let's go to a representation like this. If I said, what is your line of best fit? I could get several people come up here, draw lines. Some people's theory is, well, I'm just going to draw one that's sort of scattered. And if I did that, it might look, something like this. You know, just pretty scattered. Just came up, really didn't have a beginning or an end because the points were scattered. Okay, I'm with you. Maybe you would be more of the type of a little strategy like, well, I know there's a low point, I know there's a high point. Maybe I would make my line go through, or as close as I could, those points. So if we did the low point and the high point, something like that might be pretty close to our line. Even still, different than that, and somebody might come up and say, no, I'm going to lay mine as close to the middle of all those points as I could get, and maybe their line's going to run more like that. And so if we do this, each and every time we're seeing we got a different line. So we could be here for a while. But there's one thing all these lines do have in common, and we like to say that's their correlation. They all appear to be going up from left to right based on this data. And that is a true statement. So if we say we have a positive correlation, you're going to see a relationship of dots that do basically make your eyeballs appear to go up left to right, versus a correlation that goes down from left to right would then make your eyeballs go down from left to right. And then possibly, what if we just had random series of points where you could take your eyeballs up, you could take it down, you can take them horizontal, you can take it vertical. We would basically say there is no correlation. So we've got positive correlation, we've got negative correlation, and then we have no correlation. Those are going to be the three that we spend a little time on today. All right, in doing this though, we're all talking about the line y equals mx plus b, the one we usually graph from. It is going to be called the line of best fit. You already saw that in the direction. The least squares line and the regression line. Now, of all of these, least squares is probably the oldest. Line of regression is probably the newest. Came with technology, and that's the name you're going to see when you go and use your technology today. The R value that we're going to talk about is called the correlation coefficient. That R value will be a value that your calculator spits out. It will be a number between 1 and -1, and there are lots of numbers between 1 and -1. The sign of R, by that I mean positive or negative, okay, indicates the direction of the relation between the variables. So what we just talked about on our sequence, if we got a positive slope, then our R value will correspond to a positive value. Okay, this will have a positive R value. If our slope is negative, we have a negative correlation, then we will have a negative R value. So the sign on your R value corresponds to your positive and negative of your slope. You want all three names just because you're going to have different authors, different teachers, different professors along the way, and they could call them, any of them could be called interchangeably. Now, correlation coefficient, let's talk about it in a little more detail here. The correlation coefficient, first one is the absolute value of R indicates the strength of that linear relationship. What that means is, we just said R could be a positive or a negative value. Whether it's positive or negative just occurs or correlates to the slope. The absolute value of it indicates the strength of the linear correlation. The closer it is to 1, the stronger it is, the more perfect a fit it is. Think of it that way. When r equals 1, you have what we call a perfect linear relationship. All the points in that data line up exactly on a line. Versus the closer it is to 1, the stronger the linear relationship is. So if we had a 0.98, that would be a very strong but not perfect linear relationship. The other factor is, what if it gets closer to 0 or it equals 0? Then we know there is no linear relationship there. It indicates no correlation. Points are spread out all over the place in no particular pattern. Now, when we use these today, we're going to be doing a problem when we come to class with our calculator. So make sure you understand what a correlation coefficient is. Make sure you understand what the 3 correlations are, because we will do one problem together that will then help us determine what is that line of best fit. And our calculator will actually spit out an equation that matches or mirrors y equals mx plus b. The m value will have lots of decimals in it because of the slope, as will the b value, because the calculator is doing some number crunching, some other higher mathematical calculations that determine the best fit for all the possible values that you're giving it. All right, so we have more to come in class with our calculator.